Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Problem 138. Knowing that the discharge in pipe 3 is 60 liters per second, determine the total head loss from A to E. Also determine the equivalent length of 0.4 meter diameter pipe with friction factor 0.022 from A to E that may replace the system. So here is the given figure. So this is a system of pipe in series parallel connection. So knowing the discharge in pipe 3, which is parallel to pipe 4, then we can compute the head loss in pipe 3. From there, which is since pipe 3 is parallel to pipe 4, the head loss in pipe 4, which is equal to the head loss in pipe 3, then we use the formula by Darcy-Weisbach in terms of the discharge. Head loss equals 0.0826 FL Q square over diameter raised to 5. Then we can compute the discharge in pipe 4. Knowing the discharge in pipe 3 and pipe 4, then we can determine the discharge in pipe 5. So that is Q3 plus Q4 equals Q5. Then having known the discharge in pipe 5, we can compute the head loss in pipe 5. Since 3 and 5 combined are parallel to pipe 2, then we can compute the head loss in pipe 2, which in turn we can determine the discharge in pipe 2. Then Q1 equals Q2 plus Q3 plus Q4. So since we have found Q2, Q3, and Q4, Q3 is given, then we can compute the discharge in pipe 1, which is also equal to the discharge in pipe 6. Then, having known the discharge in pipes 1 and 6, we can compute the corresponding head losses in pipes 1 and 6. Then the total head loss from A to E would be head loss in pipe 1 plus head loss in pipe 2 plus head loss in pipe 6. So that answers this problem. Then for the equivalent length of 0.4 meter diameter pipe, I'll present two solutions. By principle, the total head loss in the system is equal to, by Darcy-Weisbach equation, 0.0826 friction factor length equivalent discharge square over diameter raised to 5. Then from there, we can compute the length, the equivalent length of the that will replace the original system. Then the other way is by Darcy-Weisbach head loss equals FL equivalent over diameter, then times velocity head of this zero point 0.4 meter diameter pipe, which is equal to Q1 equal also to Q6. Then the other way of solving for the length equivalent is from the formula K times diameter over friction factor. So it will be presented here, and you have two options to solve for the equivalent length. So for the first solution, this is the formula by Darcy-Weisbach. Head loss equals 0.0826 FLQ square over diameter to the fifth. So substitute into pipe 3. Head loss in pipe 3 is 0.0826, friction factor 0.025, length 1000, discharge 0.06 square given, over diameter to the fifth, 0.25 to the fifth. So head loss in pipe 3 is equal to 7.6124 meters. Then we equate it to head loss in pipe 4 to solve for the discharge in pipe 4. So 7.6124 is equal to 0.0826, friction factor 0.022, length 1500, Q4 square over diameter 0.35 raised to 5. So Q4 is equal to 0.12111 cubic meter per second. Then having found Q4, from the figure Q3 plus Q4 equals Q5, so we can compute Q5. So Q5 equals 0.06 Q3 plus Q4 0.12111. So it is 0.18111 cubic meters per second. Then we can now compute the head loss in pi 5 because the discharge is known. So HF5 is equal to 0.0826 times 0.02 times 800 of discharge square 0.1811 square over diameter 0.3 to the fifth. So the head loss in pi 5 is equal to 17.839 meters. Since pipe 2 is parallel to 3 and 5 combined, then HF2 equals HF3 plus HF5, or HF2 equals HF4 plus HF5. So let's use HF3 plus HF5. So HF2 equals 7.6124, HF3 plus HF5 17.839. So HF2 is equal to 25.451 meters. Having found HF2, we can now compute the discharge in pipe 2 using the Darcy-Weisbach formula again. 25.451 equals 0.0826, friction factor 0.022, length 2000, discharge Q2 square over diameter 0.4 raised to 5. So Q sub 2 is equal to 0.26778 cubic meter per second. Then we can now compute Q1 from the figure. Q1 equals Q2 plus Q3 plus Q4, and Q1 equals Q6 also. So it is 0.26778 plus 0.06 plus Q4 0.12111. So Q1, which is equal to Q6, is 0.44889 cubic meter per second. Then the total head loss, so we have to solve for HF1. So HF1 equals 0.0826, friction factor 0.023, length 1000, discharge 0.44889 square over diameter 0.5 raised to 5. So HF1 is equal to 12.25 meters. HF6 is equal to 0.0826, friction factor 0.023, length 1200, discharge 0.44889 square over diameter 0.5 raised to 5. So HF6 is equal to 14.70 meters. So finally, we can now compute the total head loss from junction A to E, and it is HF1 plus HF2 plus HF6. So head loss from A to E equals HF1 12.25 plus HF2 25.451 plus HF6 14.7. So the head loss from A to E is equal to 52.40 meters. Then the equivalent length of 0.4 meter diameter pipe with friction factor 0.022 from A to E that may replace the system. So we use Darcy-Weisbach formula where head loss is 52.4 and the discharge is 0.44889 cubic meter per second. So 52.4 equals 0.0826, friction factor 0.022, length equivalent times 0.44889 square over diameter 0.4 raised to 5. So equivalent length is equal to 1465 meters. The other way is friction factor length equivalent over diameter velocity head. So LDE, the other formula also using this, KD over F, where D is 0.4 and F is 0.022. So it is 200 over 11K. So let's compute the value of loss coefficient K per pipe for pipe 1, for pipe 2, and pipe 6. And to do that, let's solve for velocity head first, velocity of the pipe that will replace the system. So the discharge is retained 4 times discharge over pi diameter 0.4 square. So it is 3.5722 meters per second. So V1 is equal to 4 times 0.04489 divided by pi 0.5 square, and it is also equal to V sub 6 because the diameter and friction factor of pipes 1 and 6 are correspondingly the same. So 2.2862 meters per second. We then compute V2, where the discharge is 0.26778. So V1 over V, by the way, is also V sub 6 over V. So it is the ratio of 2.2862 and 3.5722, and it is 0.64. V sub 2 is 4 times discharge, 0.26778 over pi diameter 0.4 square. So it is equal to 2.1309 meters per second. Then the ratio V sub 2 over V, 2.1309 over 3.5722, is equal to 0.59652. Then the equivalent length is 200 over 11. So K sub 1, by the way, is 0.023 friction factor, length 1000 over diameter 0.5 times V1 over V quantity square. So that's K1, and K sub 1 is equal to 18.842. Next is K sub 2. K sub 6, 0.023, 1200 over zero point 0.5, 0.64 square. So that is equal to 22.610. For K sub 2, 0.022 times 2000 over zero point 0.4 times V sub 2 over V quantity square, 0.59652 quantity square. So K sub 2 is equal to 39.142. We can now compute the equivalent length using this approach, KD over F, and it is equal to 200 over 11 times the quantity K1 18.842, K2 39.142, plus K6 22.61 as shown. So the equivalent length is also 1,465 meters. Problem 139. For the series of new cast iron pipes with absolute roughness 0.26 mm shown below, changes in cross sections are sudden. Entrance and exit are flush and submerged as shown. Determine the value of big H if all losses are considered. The following data apply. Discharge 80 liters per second of water at 18 degrees Celsius with viscosity 0.00116 Pascal second. L1 is 400, diameter of pipe 1 400 mm, length of pipe 2 200 meters, diameter of pipe 2 200 mm, length of pipe 3 300 meters, diameter of pipe 3 300 millimeters. Then use the empirical formula Ks sub Sc, which is 0.42 of 1 minus the small diameter square over big diameter square at the junction, in computing for loss coefficient for sudden contraction only at the junction between pipes whenever applicable. Also compute the equivalent length of 300 mm diameter pipe that will replace the system. The friction factor of the 300 mm pipe will be determined as we move on, and this should be the final refined value of the friction factor, which is the same as this pipe 3 here, because the diameter is also 300 mm. So we learned that this H, if you write energy equation between points A and B on the surfaces of water surfaces of the reservoir, is the sum of the head losses. And the head losses consist of major and minor losses. So since the discharge is known, we can compute the average or mean velocity in each pipe. So for the solution, V sub 1 is 4 times discharge 0.08 over pi times the diameter of pipe 1 square, 0.4 square. So it is 0.63662 meters per second. Then we compute right away the velocity head, square 0.63662 square, and then divide it by 2g or 19.62, and the value of the velocity head in pipe 1 is 0.02066 meter. V sub 2 is 4 times 0.08 over pi times 0.2 quantity square. So it is equal to 2.5465 meters per second. Then the velocity head of pipe 2, 2.5465 square over 19.62 is equal to 0.33051 meter. Velocity in pipe 3, 4 times 0.08 over pi times 0.3 square, and it is equal to 1.1318 meters per second. Then the velocity head, square 1.1318 divided by 19.62. So it is equal to 0.06529 meters. So from here, we can compute the Reynolds number, and we find the friction factor needed in computing for the major head losses. And let's refine these friction factors. So Reynolds number 1 for pipe 1 is diameter 0.4, mean velocity of flow 0.63662, density of water 1000 over viscosity of water 0.00116, and that is equal to 219524, and that is highly turbulent. That's turbulent. We expect turbulent flow for this problem because the flowing liquid is water. For Reynolds number of pipe 2, diameter 0.2, mean velocity of flow 2.5465, density of water 1000 over 0.00116, viscosity of water at this temperature of 15 degrees Celsius, so it is equal to 439052, which is also turbulent. Then Reynolds number for pipe 3 is diameter 0.3, 1.1318, velocity 1000 over 0.00116, so it is equal to 292,707. We then use Colebrook's equation. 1 over square root of f equals negative 2 log of quantity E over 3.7 D plus 2.51 over Reynolds number square root of f to compute for f. So 1 over square root of f equals negative 2 log of quantity E over 3.7 D plus 2.51 over R sub E square root of f, where absolute roughness is 0.26 for new cast iron. So 1 over square root of f1 equals negative 2 log of quantity 0.26 over 3.7 times 400 plus 2.51 over 219,524 square root of f1. So using your high-tech calculator, f sub 1 is 0.01941. Then 1 over square root of f2 equals negative 2 log of quantity 0.26 over 3.7 times 200 plus 2.51 over 439,052 square root of f2. So f sub 2 is equal to 0.02152. Then 1 over square root of f3 is equal to negative 2 log of quantity 0.26 over 3.7 times 300 plus 2.51 over 292,707 square root of f3 rather. So f sub 3 is equal to 0.02006. So from here we can now compute the head loss due to friction, and we remember these velocity heads and friction factor on the next slide. So remember that this is the original problem, and we continue by computing the value of big H, which consists of head loss due to pi friction H sub f plus head loss due to minor losses H sub m. So here we go. So this is the figure. So these were the values of velocity heads and the friction factors from the preceding slide. So H equals HF plus HM, where HF is 0.01941, length of pipe 1 400 over diameter 0.4, velocity head of pipe 1 0.02066. This one. Then plus HF2, friction factor 0.02152, length to 200 over diameter 0.2, velocity head of pipe 2.33051. Then plus head lost in pipe 3, friction factor 0.02006, length 300 over diameter 0.3, velocity head 0.06529. So adding HF due to friction is 8.8233 meters. Next, we compute the loss coefficient due to sudden contraction here, which is 0.42, quantity 1 minus 200 square over 400 square, because the diameter of pipe 2, which is smaller, is 200 mm. The diameter of pipe 1, which is bigger, is 400 mm. So it is 0.315. Then we can now compute HM. So H sub M equals 0.5 at the entrance, 0.5 flash entrance. Then we have valve, which is 3, times the velocity head 0.02066. Then plus we have sudden contraction here, which is 0.315. Then we have sudden expansion, which is quantity V sub 2 minus V sub 3 square over 2G. For the next minor loss, then we have valve 5, exit submerged 1. So 3, for pipe 3 we have 1 plus 5, or 5 plus 1 times velocity head in pipe 3. So for pipe 2, 0.315 times velocity head in the smaller pipe, which is V sub 2, 0.33051. This is the head loss due to sudden contraction. Then in this junction, we have V sub 2 minus V sub 3 square over 2G. V sub 2 is 2.5465 minus V sub 3, 1.1318 from the preceding slide, quantity square over 19.62. Then plus 5, quantity 5 plus 1 times velocity head in pipe 3.06529. So adding H sub M equals 0.67017 meter. Finally, we can now compute big H. It is 8.8233 plus 0.67017. So big H, or the difference in elevation between reservoirs A and B, water surfaces A and B, is 9.493 meters. Then for the equivalent length of pipe, so by principle, head loss equals 0.0826, length equivalent. Friction factor, by the way, is 0.02006, the friction factor of pipe 3, because the diameter is the same, 300 mm. Length equivalent, discharge 0.08 square over diameter to the fifth, 0.3 to the fifth. So the equivalent length is, the other way is by FL equivalent over diameter, velocity head of pipe 3. So all these formulas will give us the same value of L sub E, which is equal to 2,175 meters rather. Then the other formula is KD over F. Length equivalent is KD over F. So by the way, these are the velocities. And V3 equals V, the velocity in the 300 mm pipe, 1.318 meters per second. So that the ratio of V1 over V is equal to 0.63662 over 1.1318. That's 0.56248. V sub 2 over V, 2.5465 over 1.1318 is 2.25. And of course, V sub 3 over V is 1. So length equivalent is KD over F. D is 0.3, F is 0.02006, and that is 14.955 of K. So for pipe 1, the total K is quantity 0.5 plus 3 plus point friction factor is of pipe 1 is 0.01941. Length is 400 over diameter 0.4 times V1 over V quantity square. So K1 total is quantity 0.5 plus 3 plus 0.01941 friction factor length over D times quantity V1 over V quantity square. So 0.63666, sorry, 0.56248 quantity square. And that is equal to 7.2484. For pipe 2, we have sudden contraction 0.315, sudden enlargement which is V2 minus V3 quantity square, but we have to divide it by V3 square or V square, which is 2.25 square. Then before we multiply everything by the same thing, 2.25 square, because V sub 2 or V is 2.25. So K2 total is equal to 0.315 plus quantity 2.25 minus 1 square over 2.25 square plus friction factor 0.02152, length 400 over 0.4 times 2.25 square. This is for pipe 2. So 112.102. Then K3 total is equal to 5 valve plus submerged exit 1. Then due to friction 0.02006, length 300 over 0.3 times V1, V3 over V, which is 1 square. Then it is 26.06 meters. So substitute L equivalent is 14.955 times the quantity K1 total plus K2 total plus K3 total. So 14.955 quantity 7.2484 plus 112.102 plus 26.06. So L equivalent total is equal to 2175, which is the same as this. But the solution is longer, but I just give you an alternate solution.